Today's topic is multiply complex numbers. You can see that we're going to simplify with imaginary numbers and multiply with complex numbers. The imaginary number is indicated with a cursive lowercase I, and we have I to the first. It is the square root of -1. So up until now, we haven't been able to take the square root of a negative value, but now we're going to be able to do that. And so I to the first is the square root of -1. Square root of -1 is going to be equal to I. That's how we'll write that down. If we continue the pattern and go to I squared, you can see that I squared is the same as I times I. The I is the square root of -1, and square root of -1 again. And so we multiply those together. The shortcut would be to write down square root of -1 where that's squared. Remember that square root and squaring are inverses of each other, so they cancel each other out. We're left with the -1. We go to I to the third power. The I times I to the second is one way to multiply to get I to the third power. Going back to I squared is the same as -1. I to the first power is the I, and so we multiply those together and we get the opposite of I, or -I. I to the fourth could be written as I squared times I squared, and I squared is -1. Replace this I squared with -1. -1 times -1 is 1. So there is a pattern going on here, and you'll want to have these four things memorized. One way to help you possibly memorize them is if you're in a game or something and you get excited because it was close, and then the game ends and you are the winner. So I won, I won. And you can see that we have I and then a 1 and an I and then a 1. And we'll have to remember that in the middle we have the negatives. We can go on with this and find out what I to the fifth is. One way to do I to the fifth would be to write down I squared times I to the third power. In which case we go back to I to the second power is -1, and then I to the third power is -I, and so when we multiply those together, then we would have equaling a positive I, and notice that's the same as I to the first. If I continue on and just kind of figure out what's going on here, I've got I to the sixth power. Well, I could write that as I to the fourth times I to the second, because remember you add the exponents together. I to the fourth, remember, is 1. I to the second is -1. And so we multiply those together, then we end up with -1. I'm starting to see something here. That's the same as I to the second power. You can eventually guess what's going to happen here with I to the seventh. I to the seventh is going to be the same as I to the third, because what's happening is I can just go through this pattern, start with 1, 2, 3, 4, 5. Remember, it's the same as I to the first. 6, I to the sixth is the same as I squared. 7, 8. So I'm just repeating this pattern. And what we're going to be doing with this then is we're going to be actually looking at some higher exponents. So we'll make a little bit of a jump here and go to I to the ninth. You can either count through the pattern, which is not too bad, or think of it this way. How many sets of fours can I get out of 9? Well, I can get I to the fourth once, I can get I to the fourth twice, and then I still have one more. So 4, 8, and then 9 would give me I to the 9. And go back to saying, okay, I to the fourth is 1, I to the fourth is 1, and I to the first is I, and so we multiply that together, and we will get I, right? The other approach is to take your exponent and divide it, because we're looking for how many times I can actually go and take 4 and go into, in this case, 9. And this, here I get 2, which you can see we got I to the fourth, I to the fourth we got twice. and then we still have 1 left over out of the 4. And so that would require us to go through the pattern twice, the whole number there. And we go through the pattern twice completely, okay? And then 1 more. So once we go through the pattern twice, once, twice, and 1 more, we are back to I to the first, and so you can see that it ended up being I to the first. Why is that beneficial? Well, because we are going to make the exponent something like 84. And so when I think of I to the 84th, I'm trying to figure out what that is. 84 divided by 4 gives me 21. So I go through the pattern and have to count through, 20 times, because 20. I'll be going through the pattern 5 times completely. So 5 times through, and then plus 1. And so that plus 1 then would mean that I to the 84th would equal I. It is possible to work it a little bit backwards, in that if I looked at what is I to the 47th, I can look at it as I to the 44th. That's the going through the pattern completely as many times as I can, which would be 11. And then I still need 3 more. And so we know I to the 44th, we're going through the pattern completely, so we don't even have to worry about that. We just look at what I to the 3rd is. And if you go back to your pattern, I to the 3rd is I1, I, and the negatives are in the middle. So if we go through that little saying, then we would end up with negative I. Okay? Or you might think about going and looking at I to the 48th. Okay, I to the 48th would be going through the pattern 12 times, but we need to go back 1. Or go backwards. In which case, we would start off at I to the 4th, which I to the 4th is your positive 1, and then if you go back 1, then you end up with I to the negative 1st. So this is the first part of simplifying with radicals, goes into this, as well as simplifying with imaginary numbers. The second portion of the video that you will need to watch is where we will multiply with complex and imaginary numbers.